Okay, starting chapter 6, we're going to expand from just plain old triangles into polygons. And in particular, we're going to focus on quadrilaterals, but we do a little polygon stuff first in the first section called angles of polygons. Quick review. Jalen, what's a polygon?
A polygon is a shape with a closed shape
I like it.
with straight sides.
Okay, good. No curved sides. Is that it?
And yes.
Read it. Yeah, talk louder. There's a tea kettle in my ear.
They don't intersect, but they don't have like closed spaces.
I understand what you're saying, but can you say it more eloquently?
There's no closed shapes within the shape.
No shapes within the shape. You were talking about this guy, right? Yeah. Where do all... Yes?
Wait, would it be, it's a closed shape with straight lines that don't
All lines are
intersect?
straight, but all straight sides.
Oh, all straight sides, with lines that don't intersect.
But they do intersect. Where do they intersect? Well, the vertex is formed by the intersection, but where do the segments intersect?
At the ends?
At the endpoints, correct. Okay, good. So the sides are segments, and those segments only intersect at their endpoints. But we knew that already. Okay. This one in the upper left is not a polygon because it's not closed. This doesn't intersect at its endpoints because you got those two meeting there, and that one's got curved sides. Beautiful. Okay, quick review. I think we did this, didn't we, Matt? All the polygon names?
Yeah, a while ago.
Yeah? You think you can fire off all of them?
Not all of them.
Come on, you baby. I have the utmost confidence in your ability. You ready?
Yep.
I'll guide you through it. I'm not gonna come back there and hold your hand or anything. I'm just gonna guide you through it. Let's start with the purple one in the upper left-hand corner. Attaboy. How about the bright green one in the upper right-hand corner? Think carefully before you answer. Beautiful, quadrilateral. Then we'll jump down to the puke green one below that. It's a building in Washington. Washington, D.C. In Washington, D.C. It's a building in Washington, D.C. It's not the White House. It's not the Capitol building.
Pentagon.
The Pentagon, good. And then go over to the white one there on the left side. It's a hexagon, good. And then let's go to the gray one.
I don't know that one, but I know next.
You want to skip that one and come back?
Yes.
Okay, let's go to the red one.
Oh, the red one, that's an octagon.
Octagon, very good. And then we go to, I believe the yellow is next.
Is that an octagon?
It is a nonagon, very good. And then the purple one?
Oh, that is a decagon.
Decagon, beautiful. The other ones we talked about were 11 sides, which is decagon is 10, so what's 11? How about 12? Well, 12 is 10 plus 2, right?
Yeah. So,
A female deer is called a...
so,
If I want your help, I'll ask for it. Okay? And if you put a bunch of cards together, you get a... Uh-huh. And if you lead somewhere, you're...
decagon.
Dodecagon, very good. Then 11 would be 10 plus 1.
Okay, so it's something decagon.
Good. What's 1 in Spanish? Uno. Right. But if you truncated that, you'd have... You said it right the first time. Un.
Un decagon.
Un decagon, good.
Okay,
You're almost there. We just need to go back to the gray one, 7 sides. So if you don't live in the city,
Yes.
if you live out in the country, and you can't tap into the sewer system of the country, you have a tank in your backyard, you know what that tank is called?
Wait, what?
I have no idea.
No idea. Okay, let me see if I can think of a different approach here.
Yeah, say it with a month. Yeah, that's easy.
Oh, yeah. What month comes after August?
September.
Uh-huh. And how do you abbreviate that?
September.
Septagon, very good. Okay, good. Triangle, quadrilateral, pentagon, hexagon, septagon. Oh, bonus question, do you know the other name for 7 sides?
I do not.
Okay?
Heptagon.
Heptagon. Yeah, I couldn't figure out how to help you with that one, so you're on your own. Heptagon, octagon, nonagon, decagon, undecagon, dodecagon. What if it's more than 12, Matt? How do you name a 37-gon? What kind of polygon? How do I distinguish a 37-gon from a 45-gon? How do I name those? Well, we know 7 is septa, and we know 30 is 3 tens. So that'd be trideca. So you can do, no, I'm just kidding, we don't do that. How do we name a 37-gon? It's a 37-gon, right. If it's more than 12, we just put the number dash gon. What if it's got n number of sides?
And number of sides.
Yeah, we don't know the number of sides. What would you call that polygon?
And polygon.
Close enough, an n-gon. Good. Don't get an n-gon confused with a nonagon. Oh, look, I got all those. Uh-huh. You didn't get the bonus question, no, I'm sorry. Next year, you'll be really concerned about octagons. Why? No, he's taking on martial arts, mixed martial arts. He's gonna be a fighter, so he's gonna be in the octagon a lot.
Oh.
Yeah. You guys didn't know that?
And it aren't stop
Because
signs
stop signs,
hexagons?
because they're gonna be driving.
No, stop signs are octagons.
We'll be driving next year.
You're right, I've only been driving for
Nice one.
40 something
Oh,
years.
wait,
so-
they are.
How's that shoe taste? Nonagon, decagon, un and dodecagon. Polygon sum theorem. So what do we know about the angle sum in a triangle? 180. Beautiful. You're just a wellspring of information today, aren't you? Love it. Okay, so here's what we're going to do. We're going to start with that triangle, and we know, as Matt just told us, that the sum of the angles in that triangle is 180 degrees. So then if I go to the right for the quadrilateral, I split that quadrilateral into 2 triangles. Each of those triangles has a sum of 180, so therefore the sum of the angles in a quadrilateral is
360.
360. Do you have too much caffeine today, Tom?
Probably.
Yeah. If we go down one, we've got a pentagon. That pentagon gets split into 3 triangles, each one having a sum of 180, and therefore the sum of the pentagon is,
720.
how about 540?
540.
That illustrates a perfect point. Let's get out our calculators, please. Instead of shouting out silly random wrong answers, let's use the calculators and get the right answers.
Thank you. I got them yesterday.
Then we move over to the hexagon. The hexagon splits into 4 triangles, each triangle having a sum of 180. Therefore, the sum of the angles in the hexagon is how much?
720.
720. Then we've got a septagon. The septagon splits into 5 triangles. 5 times 180 is
900.
900. Let's suppose I've got 15 sides. How many triangles would I get?
14.
No. Let's review. 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. Wait, I said that wrong, didn't I? 5 sides, 3 triangles. 6 sides, 4 triangles. 7 sides, 5 triangles. 15 sides,
15.
13 triangles. N sides,
And
And triangles.
N minus
N minus
N
two.
minus
N minus 2. And each of those has a sum of
180. 180.
180. So we get something called the Polygon Sum Theorem. So let's talk about the notation first. N is the number of sides. Capital S is the sum of all the interior angles. So what would be the formula for capital S? In other words, if I have a polygon with n sides, what's the sum of all the angles in that n-sided polygon? How many triangles? Kira?
Would it be S equals n minus 2 times 180?
Yes, but there's some parentheses in there.
Yeah, it would be S equals 180, what's the word for the parentheses?
Quantity.
Times the quantity of n minus 2.
Beautiful. Okay. The important thing to notice is that that doesn't tell me anything about individual angles. It just tells me what the sum is. Okay, so you can see if you look at like the quadrilateral, for instance, all those angles are different sizes. So we can't talk about individual angles. We can only talk about the sum of the angles right now, but things will change in a little bit. You know what's really cool? That Batman mirror, because of the Puerto Rico flag, makes it look like it's very American.
Yeah.
I saw that yesterday.
Wait, why do you have a Puerto Rico flag?
Because I went to Puerto Rico 2 years ago. Stole that, I bought that flag. It was a lot of fun, yeah.
Are you allowed back in Puerto Rico?
As far as I know, yes. Corollary. If you'll recall, well, I'll ask you, what's a corollary?
No idea.
You should, we've used the word before. Matt?
It's a measure of an interior.
No. Has nothing to do with what's written below it. I'm just wondering what a corollary is. Anybody? Corollary is a sum theorem. It's a theorem that's not important enough, because this is a Polygon Sum Theorem. It's a theorem that's not important enough to get its own theorem. So it goes below another theorem. Okay, so let's go back here. Here I take any polygon and I can find the sum of the angles. Now, if it's a regular polygon, Sarah, refresh my memory on what a regular polygon is. Oh, what's up?
Where it's equilateral and equilateral.
Beautiful. Equilateral and equiangular, meaning all the sides are the same and all the angles are the same. So if all the angles are the same, then we can take the sum and divide it by the number of angles. Okay, so if I know the sum in an octagon and all 8 of the angles are the same measure, I could just divide by 8, and lo and behold, we got the measure of each individual angle. That only works, however, in regular polygons, hence the reason that's in italics and red. But some of you will try to do that with a regular old polygon, and I will just throw my head back and laugh. Shall we do some examples? Beautiful. Find some of the interior angles in a nonagon. Do it! If you're not already doing so, start with a blank formula. Emily, what blank formula are we using for this problem?
Is it 9 or n minus 2 times 180?
Beautiful. And what does that equal?
The interior.
Yeah. What variable?
No.
Yeah, capital S, correct. So it's an equation, so start with an equation. Don't just randomly start spewing things out. S is equal to n minus 2 times 180. Start with the blank formula, plug in what you know. Emily, what do you know in this problem?
That it has 9 sides.
Is that n or s? N, beautiful. Plug in 9 for n, solve. And what do you get, Emily?
Excellent. I got one.
No. Sum. Because we don't know it's regular, so you can't divide by 9. So what should it be?
Wait, what?
Should be a big honking number.
Okay, then it's 1,260. 1,260.
Yes?
Yeah.
Beautiful, 1,260. Is everybody good with that? Beautiful. Number 2, find the measure of all 4 angles in that quadrilateral. What kind of quadrilateral is that, Alex? That's the dumbest question I've ever asked. I meant to ask what kind of polygon is that, but I've already told you it's a quadrilateral. Good job, Alex, way to go. Way to pay attention. Let me try another question just to redeem myself. Alex, what are the sum of the angles in that polygon / quadrilateral?
360.
Beautiful, thank you. Very colorful. Tricia, what'd you get for X?
I got 11.
Somebody confirm? 11? How'd you get that?
I added all of them up. I added all the angles and set it equal to 360.
Beautiful. Get the angle measures too? Also, I should say.
And multiply.
Okay. Yes? Do you have a question? Oh, just stretching? In case things get crazy, you want to be loosened up before you go into the calculation. Did you have a question?
I think I
Hold on, I'll give Tricia a shot. If she stumbles, I'll come back to one of you guys. Loosen it up. I understand. Did you get them? 55 and 125. How'd she do?
Yeah.
Well done. Okay. It's a quadrilateral, therefore the sum of the angles is 360. She added up all 4 angles, set them equal to 360, solve for x, got 11, right? Then plug that value back in to find the measure of all the angles. Beautiful. There's all the work, which I assume yours looks just like that, right? Is it in red also? Okay, so it doesn't look just like that. Kind of close. Okay. All right, try that one on for size. Let me know if you need help with any of the big words. Simon, what do you got?
6, sorry. I got x equals 40 and 6 of the angles are 40 degrees and the other 2 are 60.
How do you do? Oh, they don't like that. Tell us what you did.
Well, since 6 of the, wait. Yes, since 6 of the 8 angles are the same, I put them as x,
Good,
and then the other 2 I put x plus 20.
good.
Then I added all of it together. I got 8x plus 40 equals 360.
Ooh,
Or
hold
not,
on a second. What kind of shape are we dealing
That's
with?
not
Oh boy. So it's not 360, what
Yeah.
should it be?
1080.
1080, correct. 8 minus 2 times 180, 1080. Then you solve for x, then you plug it back in. So your method was correct, you made the mistake of using the wrong value, but remember it is an octagon, so it should be 1080, not 360. When you do that, somebody else, what's x? 130. So therefore you should have 130 and 150 as your possible angle measures. Okay, any problems with that? Good. That n minus 2 times 180 calculation you're going to do over and over and over again to the point where you will probably know automatically that an octagon is 1080, that a hexagon is
720.
720. All right, find x. Oh, hold on. Before you find x, let me ask you a question. What's wrong with that picture? This is kind of persnickety, but it bothers me, and I didn't realize it until just now. Kira.
It says that those angles are equal, but they're not.
Right, I use the same angle measure for all those angles, and they're not the same. So trust the angle measures, not the tick marks that I used inappropriately. Thank you, that is all. Carry on. Hey everybody, it's Mr. Minter. Morning. What's happening? Walking around. I understand. Question, Tom? Already?
Yeah.
Wow, you're a smart feller. What's n in this case?
N would be 6.
Okay, good. We'll come back to you in a second. Don't look so hurt. Just want to give everybody a chance. You work faster than others. I hope you're right, though. Did you check with anybody? So just 2 of you have it. What if he's wrong also?
I believe
He didn't say the answer yet. I just asked him what n was to make sure he could count to 6 and make sure he knew that was a hexagon. All right, are we good? Everybody got an answer? All right, Tom, share with us.
Well, I did.
Wait, hold on. Before you go into a lengthy explanation that can take 20 minutes, what'd you get for an answer?
X is 110.
110, anybody? Oh, they're feeling good about that one. All right, how'd you get 110?
Well, I did the thing where you do the n, the quantity of n minus
Hold on,
2.
what's that thing called?
I forgot. I don't know the name of it.
The Polygon
yeah.
Sum Theorem. What do you say?
Thank you so much.
There you go.
Okay.
Okay, so you did that thing.
And I got, I think it was 720.
Right, because
Yeah.
that's what you just told me was
Yeah.
hexagon. Good,
uh-huh.
good. Yep.
And then I did 720 minus 120 minus 110 minus 90 minus 130 minus 160, and I got 110.
Sounds pretty good to me. Any questions? Well done. Okay, so we've done a ton with exterior angle. We had the exterior angle theorem, which said an exterior angle is equal to the sum of the opposite 2 angles. Then we just did an inequality thing with exterior angles, where the exterior angle is greater than the other 2. Now we've got an exterior angle sum theorem. And so, what happens when we add up all the exterior angles in a polygon? So in your notes, draw a picture of a square. I think you should all know what a square is. And at each of those vertices, draw an exterior angle. First of all, how big are the angles in a square?
90 degrees.
90 degrees. So therefore, how big would all the exterior angles be?
90 degrees.
90 degrees. And if I add up all those exterior angles, what do I get for a total? 360, because 90 times 4 is 360. Okay, draw a triangle now. And draw in an exterior angle at each vertex. Do you have any idea what the sum of those exterior angles is?
180.
180. So a triangle is 180, a quadrilateral is 360? Yes?
Yes.
Something doesn't seem right here, kids. Where's my pen? Are we good here? Okay, good. So you drew a square. 90, 90, 90, 90. Exterior angle, exterior angle, exterior angle, exterior angle. 90, 90, 90. 360. Any problems there? Any problems there?
No.
Good. Triangle. Exterior angle. Exterior angle. Exterior angle. Let's call that 1. Let's call that 2. Let's call that 3. And you're telling me that 1 plus 2 plus 3 is equal to 180?
No.
No. No.
They're
Why
all-
not?
They're all obtuse, and that means if two obtuse angles would be more than 180.
Okay, so how do we figure out what angle 1 plus angle 2 plus angle 3 equals?
We don't.
You don't. There you go. Good answer. Okay, let's move on then. Here, just to make things simpler, let's go alpha, beta, and gamma. What do we know about alpha, beta, and gamma? Jillian?
Well, beta plus, I think it's gamma. Beta plus gamma equals angle 2.
Uh-huh.
And then beta plus alpha equals angle 3.
Uh-huh.
And alpha plus gamma equals angle 1.
Beautiful. Should I write all that down?
It's okay.
Okay, so you said beta plus gamma equals 2. And you said alpha plus gamma equals 1. And the third one was, which one am I missing?
Beta plus alpha.
Beta plus alpha. Oh, that's a pitiful beta. Beta plus alpha is 3. Okay, good. What else do we know about that picture? Oh, keep going.
Beta plus alpha plus gamma equals 180.
Alpha plus beta plus gamma equals 180. Good. What else do we know? We're almost there. Oh, keep going.
Well, I think, is it like gamma plus angle 3 equals 180? Or equals,
Yeah.
yeah, equals 180.
So gamma plus 3 equals $180.
And then like
Alpha plus 2 equals 180.
for alpha.
And beta plus 1 equals 180. Now we've just rattled off about 37 different formulas. How does that tell me what 1 plus 2 plus 3 equals? Any ideas? Yes, Tom?
360.
What? Are you just randomly shouting out numbers?
No. It's because they'd be double what?
What's 180 times 3?
540.
540.
Isn't it 540?
180 times 3 is 540, yes. But he said 360.
Yeah, because it'd be double what?
Double 540,
No,
1080.
it'd be double alpha, beta, gamma.
Why?
Because
Christian?
Is the triangle equiangular?
Doesn't have to be. I just happen to draw looking that way, but we want to be able to do this for any triangle. That's why I didn't put numbers in there.
Well, since like one of the exterior angles equals two of the interior angles, would that mean that it's 360? Cause it's
So you're staying with his 360 argument.
yeah.
Hold on.
Well, let's go with, let's use this chunk of information here. What if I add all that together? So let's add the, we'll do this up across the top. Let's add the left side together, and we get 1 plus 2 plus 3 plus alpha plus beta plus gamma is equal to 540. How does that help us? Ooh, there's the 540.
Oh, and then you subtract 180. because
Why?
Alpha, beta, and gamma all equal 180.
This equals 180.
So you just subtract 180.
And we find that angle 1 plus angle 2 plus angle 3 equals
360.
360. Nice. Okay, let's see how you do on pattern recognition.
Yes, I'm good at this.
We took a quadrilateral, and the sum of the exterior angles was 360. We took a triangle, we actually went backwards. The sum of the... Do you have to go to the bathroom?
No, I know the answer.
I haven't asked a question yet.
I know, but I
We
know.
took the sum of the angles, exterior angles in a triangle, and we got 360. So therefore, what's the capital of Peru?
What if you actually said it?
I actually, Guatemala City.
I'm sorry, what?
Guanama City.
Did you just make up a place?
No, isn't
Guatemala
Guatemala City a place?
It is Lima, yes.
Oh, Lima.
No.
Good job. You just repeated whatever you heard. You're like a parrot.
What's the capital?
Oh, I'm gonna regret this. Yes, Tom.
Okay, so that means every exterior angle is equal, every sum of the exterior angles is equal to 360.
Any polygon?
Yeah.
What if it's got 42 sides?
Then,
What if you double what's inside of the polygon?
Ooh, that's an interesting thought. So that would mean that if, yeah, that's 360. 360. 180, 360.
yeah, see, I'm right.
Okay, notice in the triangle, all the exterior angles in this particular triangle are obtuse. When I move over to the quadrilateral, just because I chose a square, they're right angles. What happens when I go to a pentagon? What's going to happen to the size of the exterior angles? Why? So what's happening to the interior angles? As the number of sides of the polygon increases, what happens to the interior angles? They increase, they get bigger, and so therefore if the interior angles get bigger, the exterior angles have to get smaller. Correct. So for, what?
I'm right then, right?
About what?
About the 360.
No, you missed this. It was Lima, not Kuala Lumpur or whatever you said. What
It's
did,
like
what did you
Guatemala
say?
City.
Guatemala City.
Guatemala City.
He said guano.
I thought you said like Guano City.
Yeah, that's what he said.
Did you say Guano City?
He said Guanama.
Bat Poop City? Guano is bat poop, you know? Did you know that?
No.
It is.
Yeah, now you've learned something. Guano is.
There was like a book that like was about bats. It was like a picture book.
360. Doesn't matter the shape. The sum of the exterior angles will always be 360.
What'd you guess?
Don't throw your shoulder out, patting yourself on the back there, Sparky.
Yeah, he'll do it for me.
Yeah. He's got your back.
Yeah. Yeah.
We can go back for a second.
Too fast?
Okay, I'm good.
Okay, 360. So, how big is one exterior angle in a regular decagon? What's n?
8.
It's a decagon.
10.
10. How big is each exterior angle?
360 divided by 10.
360 divided by 10, which is 36. So now we get an interesting dilemma here. Not a dilemma, an interesting way to approach problems. Let's suppose I ask you, this is a regular decagon. I ask you for the measure of that angle. There's two ways I can do that now. One way would be to use the corollary, n minus 2 times 180 divided by n. 10 minus 2 times 180 divided by n divided by 10 would give me 36. No, it wouldn't. I lied. Would give me 144. Or, if you're sneaky about it, find the exterior angle, which we just did. That's 36. And what's the relationship between an interior and exterior angle in a polygon? Supplementary. So if you're looking for an interior, you can find the exterior and then take the supplement. It's a little bit easier. Either one, doesn't matter. You're going to get the same results. You can do it however you like. Remember, this formula, however, only works for a regular polygon. The 360 thing works for any polygon. Natalie, question?
Wait, what's the other way you can do it if it's not a regular?
You can't.
Oh.
Yeah, I can't find a specific interior angle if it's not regular because they can all be different.
So
Matt?
for any polygon, you can just take 360 and divide it by the number of sides and find the
Measure one angle. If it's regular.
Okay.
Yeah, it's got to be regular in order for that to happen. Otherwise, all you know is the sum. Wow, that green was a good choice on white. Holy smokes. All right, find x and the measure of ABC. It's easy as 1, 2, 3. Do, re, mi. That's Jackson 5, in case you're wondering. What's n in this case? 5. Bueno. 5. If you were in Lima. Or Guano City. All those angles that I have marked in that picture, what kind of angles are those?
Exterior.
They're exterior. What do you know about the sum of the exterior angles in any polygon?
360.
360. So what do we do with all those exterior angles? Add them up. Do we?
We add them up and set them equal to 360.
And when you do that, what do you get for x?
30.
30. So then how do I take that information and find angle ABC?
Well, you know that the exterior angle is 4x, and you know that you just plug in the value for x, and you subtract that from 180, and you get that angle ABC equals 60.
Well done. When you start these problems, make sure you identify the number of sides first.
Wait, can you repeat that again? What did you say?
Regardless of what n is, we know that all these marked angles are exterior angles in a polygon, so they have to add up to be 360. So she added all 5 of those up, set them equal to 360, solve for x. Got 30. Then to find angle ABC, she could find this exterior angle, which is 4x. So 4 times 30 is 120, and then these two are, because an interior and an exterior angle are always supplementary. So 180 minus that 120 gave her 60. Okay, we good? All done with day 1. So, again, refreshing your memory on what's going to happen this week. Tomorrow we will go over this homework from day 1. Then we'll start talking about some quadrilaterals. Tomorrow we'll start with parallelograms. The entire chapter 6 just moves from quadrilateral to quadrilateral to quadrilateral. Tomorrow we'll talk about all the different things that are associated with parallelograms. Then you go away, come back on Friday, we'll go over those parallelogram stuff. Got a quick quiz for you. Boom, out the door, winter break, nothing to do. Come back from winter break, pick up where we left off, finish chapter 6, take the test on chapter 6, review for the final, take the final exam. Semester 1, boom, in the can. We good?
You make it sound so easy.
Oh, it is cake. Come on, what's the worst that could happen?